Okay, let's dive into this. We're going to talk about the invisible architecture that keeps our digital lives safe. We're going to break down what it really takes to build a secure app. And here's a hint, it's not magic. It's all about a deliberate process of architecting integrity right into the code from the get-go. So, when you think about an app you just love using, what comes to mind? Is it the sleek design? The cool features? How fast it is? Yeah, all that's super important for sure. But there's this other thing, this critical, almost invisible element that holds it all together. Security. That's the real foundation, right? It's all about the trust between you and the app.
And this quote just hits the nail on the head. Security is not a feature, it's a responsibility. I mean, think about that. It's not just another item you can check off a list. It's this deep, fundamental responsibility that has to be woven into the very fabric of an app, right from day one.
Okay, so to really get our heads around this, let's use an analogy. Think of building a secure app, like you're the architect of a digital fortress. Seriously, every single decision you make, every line of code you write, it's like laying another stone in the wall, and each one impacts the safety of everything and everyone inside. I mean, a real fortress, its strength comes from that initial design, right? How thick are the walls? Where do you put the towers? You'd never build a flimsy little wooden hut and then think, I'll just slap some stones on it later. That's not going to work. And it's the exact same thing with app security. It's not an afterthought. It has to be the blueprint from the very start.
All right, so let's start building our fortress. First up, the perimeter. We're talking about guarding the digital gates. How does an app protect itself and control who, and just as importantly, what gets inside? This is all about that critical first line of defense. This perimeter defense really has three key layers. Let's start with the first one, input validation. The best way to think about this is like having a bouncer at the gate of a club. He's checking what people are trying to bring inside. This is what stops malicious code from getting in. A classic example is something called an SQL injection. That's where a hacker tries to sneak nasty database commands into a totally normal-looking login form to steal all your data. Input validation is the bouncer that says, nope, you're not getting in with that.
Okay, this brings us to something people mix up all the time. Authentication versus authorization. They sound similar, but they're totally different. Authentication is just proving who you are. Think of it like using your Face ID to show the guard at the gate. Yep, that's me. Authorization, on the other hand, is about what you're allowed to do once you're inside. It's like the key card the guard gives you. It'll open the door to your own profile, but it's not going to open the admin's control room. See the difference? Who you are versus what you can do.
All right, so we've secured the gates, the bouncers are in place, but now, what about the really valuable stuff inside the fortress? We're talking about the crown jewels, the user's data. Protecting that is the next absolutely critical step.
And our number one tool for protecting that data is encryption. All that means is scrambling the data so it's just a bunch of unreadable nonsense to anyone who's not supposed to see it. Now, data needs to be protected in two different states. You've got data at rest, that's when it's just sitting there. Encrypting that is like locking your treasure up in a giant steel vault. Then you've got data in transit, when it's moving across the internet. Encrypting that, usually with HTTPS, is like putting your treasure in an armored car. And you absolutely positively need both.
Oh man, this next one is a huge no-no. Never, ever hard-code your secrets. So what does that even mean? It means embedding stuff like API keys or passwords directly into the app source code. In our fortress analogy, this is literally like carving the combination to the main vault right onto the front door. I'm not kidding. It's a massive vulnerability, and you'd be shocked how often it happens. So if you can't carve the combo on the door, where does it go? Well, just like a real building, an app has specific, safe places for valuables. The keychain is that reinforced, super secure vault. It's built specifically for things like passwords and tokens. Now, on the flip side, storing that same sensitive data in a place like user defaults, well, that's the digital equivalent of writing your passwords on a sticky note and leaving it on your desk for anyone to see. Don't do it.
Okay, so our fortress is built, the treasure is secure, but we're not done, not even close. A fortress isn't something you just build and walk away from, right? It needs constant maintenance, vigilance, good housekeeping, to make sure tiny cracks don't turn into huge holes over time.
And a huge part of that maintenance is a principle called minimizing the attack surface. Here's what that means. Every single permission your app asks for, location, camera, you name it, every extra feature, every third-party library you pull in. Think of each one as another door or window being added to your fortress. The more doors and windows you have, the more places you have to guard. So fewer doors, fewer problems. It's that simple.
You know what else is crucial?
how your app handles errors. A bad error message, like this one on the left, is like one of your Fortress guards totally panicking and just shouting out secrets. Oh no, the connection failed at this specific address. It basically tells attackers exactly where to look. A good error message, on the other hand, stays cool. It's like a guard that just says, oops, something went wrong, please try again later. It gives the user what they need and nothing more to a potential attacker.
And this all leads to a really important point. When it comes to security, don't try to reinvent the wheel. Seriously, this is not the place to be a hero and build your own security tools from scratch. Apple gives developers these amazing, battle-tested frameworks like CryptoKit. Using them is like buying a vault from the world's best security company instead of trying to weld one together yourself in your garage. One is a lot more likely to work.
Okay, let's zoom out for a second and bring this all together. We've talked about blueprints, guarding the gates, protecting the crown jewels, maintaining the walls. But what's the point of all of it? All these technical details serve one single, incredibly important purpose.
And this is it. This is what it all comes down to. Every single security measure we've talked about, from that bouncer at the gate to the armored car for your data, it's all an act of building trust with the real person on the other side of the screen.
And trust is the foundation of great software. That's the ultimate takeaway here. All that complex architecture, all that careful planning, it's all in service of that one simple idea. Trust is the bedrock. Without it, the most beautiful app with the coolest features, well, it's just a fortress built on sand.
So, I'll just leave you with this final thought. The next time you log into an app, maybe with your face or a password, just for a second, think about that invisible fortress that was built all around your data, and think about the architects who worked tirelessly behind the scenes to make sure its walls are strong enough to protect you.